you're probably here because you want to learn about resilience, right? So you've probably gotten questions from your company or your business saying, "Hey, we need to improve the resilience of our systems." You maybe, hopefully, not have been through an outage in the past, an outage or two in the past. My team and I are within enterprise support, which you might have heard of, if you're an AWS customer. And what we primarily do is help customers improve their usage of AWS services. And resilience is one of those aspects that we really, really focus on. So what to expect from this session is, exploring advanced techniques we've seen customers use on resilience and the culture of building resilient applications. I still see a lot of red on your headphones, so you may have to. Okay, if you can hear me, that's fine. All right. You will get direct. What you should expect from the session is direct guidance, not it depends kind of answers, but direct direction on what to do in certain scenarios. We'll see a pre-recorded demo. It's not live, not to tempt the demo gods. And we'll also talk about what some of our customers are doing in terms of resilience. Also, just to make clear what our scope is for today, we're not going to go into specific resilience features of AWS services, but more rather, how do you build a culture of resilience within your company and your business, and then talking through some of the AWS services that will support you in that journey. There are a lot of AWS services you may or may not have heard of that can help you in your journey of continuous resilience and disaster recovery and testing. So that's what we're going to talk about today. We're not going to go into deep dives of how to do things like, RDS multi-AZ. So let's first, define what resilience is. It's the ability of an application or a system to continue do what it's, continue providing the business outcome or the business benefit it's supposed to, provide in the face of a disruption, right? So it's not necessarily, disaster recovery, but if something happens, the system must be able to continue providing the business value that it provides. And an analogy that we like to use in the space of resilience is a cake. Resilience is multi-layered. It starts with the infrastructure, the AWS services, AZs, global infrastructure that you use to run your applications. And then at the middle layer, there's more the infrastructure that's on your side of the responsibility. The operating systems, the databases that run your applications. And at the very top is the actual reason we're all here, right? To run applications that provide some kind of business value. So when thinking about resilience, don't just think of it in the context of, the infrastructure must be resilient, but at every single layer of the stack, how are you thinking about, the resilience of your applications? This is a 300 level talk, so we assume that you're familiar with how AWS infrastructure works, the difference between a region and an AZ. We have 37 global regions that have been launched so far across 117 availability zones. And you should also know what an availability zone is, right? Each geographic region, like the Cape Town region, has multiple availability zones. And the availability zones don't share power, they don't share cooling, they don't share backup power supply or anything like that. Completely separate, close enough to allow synchronous replication for things like S3 that are regional services, but far enough such that things like floodplains aren't shared, power isn't shared, there's no shared infrastructure between the availability zones. One thing that most customers don't know is each AZ could compromise, you could have multiple data centers in that one availability zone. Continuing on how AWS services are built, we have a concept of services that are zonal services, regional services, and global services. So talking through this, just to provide you some background on how we build AWS services so that we can get to the meat of resilience. Zonal services are services like EC2, EBS, RDS, where the resource that you're provisioning lives within a single zone, right? And a lot of these services, while they have regional control planes, they often have some components of the control planes that sit within the AZ, so that we have that AZ independence during an outage. And in these kinds of services, for most of them, the planes of access, how you access the resources, is separate from the control plane. The control plane is how you spin up the resource, create the EBS volume or create the EC2 instance. while your SSH connection or your RDP connection to that EC2 instance is a separate plane, so completely separate infrastructure that runs this, the data plane and control plane. And then we've got regional services. So it's services that that, and you use today for your applications like DynamoDB, S3, things like Lambda, SQS, API Gateway. These services are built across multiple AZs. So taking away that decision or design from you, having to build across multiple AZs, you can just use these regional services to take advantage of the regional nature of running across multiple AZs. If you think about these services, for most of them, the data plane and control plane is always an API, right? In the case of EC2, using an EC2 instance means using the TCP/IP network to connect to the instance, but the control plane is an API to stop or start that instance. But in case of services like S3, your interaction with the service to create the bucket or to manage the bucket is an API, but your interaction to actually put objects in the bucket or use data plane is also an API. So something to keep in mind when using these regional services. Then we've got a small set of services that are actually global in nature. And what this means is that, while the control plane of these services might sit in one region, the data plane themselves is global in nature and they sit in all regions. And a good example of this is IAM, where, an IAM identity like a user, a role, or a principal is global across, the commercial partition of AWS. But the data plane to create a session from that role, which is the session token service, is regional, and it runs in the region itself. So another thing to think about when building these services. And one guidance that we have with global services is, in terms of your recovery path, do not depend on the control plane operations of these global services, rather rely on the data plane operations. So if you think about it, there's one control plane for the service, but 37 data planes across all the regions for the services. So it's statistically more likely that the control plane is going to fail than the data plane itself. And an example of implementation of this is with Route 53 for DNS. So if you're depending on DNS to move user traffic from one destination to another, if there's a control plane failure of Route 53, you might not be able to make your DNS updates to point to the other destination. The right thing to do here is use things like Route 53 health checks, which runs in the data plane, such that if there is a failure of one endpoint, the Route 53 automatically moves your users or the DNS response to the other, to the healthy endpoint. There is a very good blog post that goes into a lot more detail about the fault isolation boundaries. I highly recommend taking a look at it. The reason why it is important is you have to keep these fault isolation boundaries in mind when building and designing highly resilient workloads and applications. Another concept we've seen a lot of customers talk to us about is static stability. Essentially, it's the ability of a system to continue operating and heal itself without requiring an operator or an engineer to make a change. So it means the system can heal itself without an operator making a change. And the reason why this is important is because, again, the control plane may or may not be available to make that change that the engineer needs to make to recover the system. And it also just takes a while to get a human involved in an incident and then getting up to speed, reading the run book, and making the change. A good example of this implementation is Lambda. So as a regional service, Lambda actually underneath uses EC2, right? There are about 80 plus microservices that run Lambda and make Lambda work for you for invocations. But Lambda has also implemented static stability such that they have health checks running, looking at the health of each of the availability zones they run in. And when they determine that there might be a problem in one of the AZs, the system automatically drains customer traffic away from that unhealthy AZ. And what they've done is, because this is critical to customers using and the expectations customers have of Lambda, they have pre-built capacity in the other AZs to take the load of the AZ that's now at fault, right? So this is static stability in play. If you had to, if Lambda had to start, scaling up more compute in the other AZs, what if the control plane at that point is impaired and you can't really spin up EC2 instance? So that's static stability in play there. And this is something we recommend customers to do for super critical workloads. Customers asked us for a way to do this themselves, right? Like, how do we do this shift from one AZ to another during a health issue or during an incident? And we released a service in reInvent 2023 called Application Recovery Controller, or ARC for short. Essentially, what the service does is that it monitors the health of the AZs, and using DNS, you can automatically route traffic away from an unhealthy AZ to the surviving AZs. You can also implement it in notification-only mode, such that when AWS detects a problem with an AZ, you get notified of that issue, and we send out that notification when AWS itself starts evacuating an AZ for regional services. So you can also take advantage of that same signal AWS is using for its services. There's also a very good blog post on this. Again, we try to be very direct in this session about what the recommendations are. So take a look at the blog post about how to use availability zones to achieve static stability. You've probably heard this quote a lot from our CTO of Amazon, Werner Vogels. He says, everything fails all the time. But we actually don't have to accept that things fail all the time. We can design for failure into our applications, and that's the whole point. That's the whole reason why you're here, right? To hear about resilience. But a quick reminder before we get into the next few slides is resilience is a shared responsibility. While AWS is responsible for using commercially reasonable means to make sure that the infrastructure, the AZs, the data centers, and the global network is highly resilient, it is your responsibility to implement the features that each service provides to make your applications resilient. And it's also your responsibility to make sure that you're doing things like continuous testing to verify your resilience posture of your applications. So again, it's a shared responsibility. AWS has its parts to play in that responsibility, but you as a customer, as a builder running on AWS also has a role to play. And that's where we go into continuous resilience. What we mean by foundational resilience is, the features, implementing the features in the services that you use to make sure they're highly available, right? So, for example, running across multiple AZs, designing to run across multiple AZs, implementing multi-AZ in RDS, just a few examples. But continuous resilience is that, practice as an organization to continuously verify that you are resilient, and not just doing it as a one-time exercise, in the design phase, but doing it continuously. And there are a number of services that, AWS has in its catalog to help you with this continuous resilience. An example of that is Resilience Hub. It's a service that helps you assess your applications against resilience goals that you've defined as an organization, and would actually go, assess how you've configured the resources in your application against the RPO and RTO goals that you've set for that application. We've got services like fault injection, which I'll talk about quite a bit in this session, which you can use to actually test your application against failure modes that you expect your application to survive. And then also a call out to the solutions library. If you Google the AWS Solutions Library, it's a link to a number of AWS approved solutions on resilience, and it contains a lot of open source resources and code to help you get started quickly with different patterns of resilience for your application. So highly recommend checking the solutions library. All right, so I want to talk about some of the trends we see customers talking to us about in the space of resilience, starting with the demand for resilience testing. A lot of customers still do ad hoc testing, where they do an annual or quarterly disaster recovery exercise. But a lot more customers now are asking us to continuously verify that their applications are resilient. And that's why we have services like the Fault Injection Service and Resilience Hub. A lot of customers are building these services into their CI/CD pipelines, doing things like validating your new CloudFormation template meets the resilience posture that you need to meet before you release it to production. A lot of customers are doing things like Canary releasing their new versions of their applications, whereby, the new version only gets a small percentage of traffic, and over time you gradually increase that load. And if there's a change in the user experience on your applications, you can quickly roll back to the previous version. We see a lot of customers doing this, and a lot of these features are built into services like the AWS load balancers and Route 53 that help you do canary releases across your traffic routing. Another trend we're seeing is multi-region, and for various reasons, depending on the industry. We've got customers in financial services, for example, that want to run applications multi-region. For one reason could be the criticality of the application and wanting to survive a regional issue. Another could be just data residency and making sure the data is as close as possible to where their users are. We've also got customers in automotive, for example, that are running multi-region because they have to reach a global scale of customers across the world for their automotive and aviation fleets. And then the third trend we're seeing here is more and more customers want to talk to us about building a culture of resilience and asking us, how do we build a culture of resilience into our organization and into how we operate, into how our engineering teams build, design, and release applications. And to help answer this, we developed something called the Resilience Lifecycle Framework. So we developed this based on many years of working with customers, but also learnings from AWS building and running highly resilient services. And the lifecycle framework is, has 5 stages, but you can enter into any stage depending on where you are in the stage of building your application. Starting with, setting the objectives of the application, then designing against those objectives, testing your hypothesis on the failure modes that you need to survive, and then doing the normal operations of your application. And then when something does go wrong, which it will, remember everything fails, at some point, making sure that you have the right practices and tools in place to respond and quickly recover from those issues. So the rest of this talk is I'm going to talk through what the patterns and the practices are for each stage of the Resilience Lifecycle Framework. And I'll also go into a quick demo in the test and evaluate phase to show you how to use services like FIS, the fault injection service, to test your applications. So the start of the lifecycle framework is setting your objectives, right? So at this phase, this is when you're defining what your expectations are for your applications. And we believe this is a collaborative process or exercise between the technical teams and the business teams. The reason why that is because the technical teams don't have all the context to make a decision on what application is most critical to the organization. What are your contractual SLAs with your end customers? What user stories within a single application is most important to the company's business objectives. So this is when again, it's a collaborative experience to define objectives like RP or RTO for your application, and again, do things like prioritizing workloads based on the importance to the business. Unfortunately, we don't have any AWS services to help you at this stage, right? But the guidance of your AWS account teams that work with you is there to help you if you ever need help talking through how to set the objectives for your applications. So now that you know what's critical to your application, it's time to design and implement. So this is when you're using things like the well-architected framework, things like the AWS white papers on the resilience best practices for each service to design and implement in a resilient way, doing things like multi-AZ, turning on automatic recovery on EC2 instances, and so on and so forth. It's also doing things like dependency mapping for your applications, right? If you don't know what dependencies your applications have, you don't know what dependencies to go make resilient or to focus on. So there's tools like AWS VPC flow logs or X-ray that can help you do that dependency mapping to figure out what is your application speaking to and what do you need to, so that you know what your dependencies are for your applications. There's things like the well-architected framework that has a whole pillar focused on resilience. And diving into that, The reliability pillar of the well-architected framework has a number of design principles, and hopefully you're familiar with the well-architected framework. But it's principles like use auto-scaling so that you don't have to guess capacity. We see a lot of applications, having faults because they, are inundated by load. There's design principles such as managing change through automation. Instead of making big, large changes to your application, put it in code, infrastructure as code with things like Terraform or CloudFormation, and make small incremental changes that you can easily roll back should you see a fault or a change in user experience. So the next phase here is evaluate and test, right? So now that you've designed, you've implemented the best practices for the AWS services you're using. You've gone through the well-architected review. You know where you need to improve. It's time to actually prove that your application can meet or can survive the failure modes that you expect it to survive. So at this phase, we're doing things like fault injection and game days, and I'll talk a lot about the services that can help in this space. But also doing things like benchmarking the performance of your applications using observability tools like CloudWatch or partner tools like Datadog or AppDynamics from Cisco. We also expect customers to do a lot of load testing. If you don't understand the performance limits of your application, how would you know at what point you need to configure your application to scale? So doing that continuous load testing with things like SolarWinds or JMeter, which is an open source tool, is very useful at this phase. And again, some of the services and tools here are things like Trusted Advisor, Resilience Hub that I spoke about to assess the posture of your application. CloudWatch is a very, very good tool here to also help you with this phase. But also things like the AWS Fault Injection Service. So a little bit about the Fault Injection Service. I like to use FIS for short. It's a fully managed service for running fault injections into your applications and doing experiments in a very safe way. So the whole point of FIS is to be able to test your production and non-production workloads to see if they can survive certain failure modes that you expect your application to survive. We make it very easy to get started with FIS. And there are lots of there's a lot of guidance on the console itself and with the service that makes it easy to test real-world scenarios, and I'll show you some of those. And there's also features in FIS that help you make sure that you're running these experiments in a safe way. For example, you can configure your experiments to pause or roll back if a CloudWatch alarm goes into an alarm state. For example, that alarm could be something that's monitoring your customer experience on a production application. So in getting started very easily, we have a scenario library that you can just get, you can just use off the shelf with the FIS service that tests things like cross-region connectivity loss for customers that are building multi-region, stress test your compute for, network or CPU performance. And it's just, getting started is just about taking one of these scenarios, selecting the accounts you want to run it on. You can run it in a single account, the experiment in a single account or in multiple accounts. And then review the actions that scenario is going to take. Configure what targets, what resources the actions should target, like what EBS volumes, what EC2 instances, what databases, and then running the experiment. But one particular scenario I want to talk about is the availability zone power loss scenario. We built the scenario specifically to help customers that are running multi-AZ test that their applications can actually survive the loss of an AZ. So if you take a typical application like this, where you have, compute running in auto-scaling groups, which is best practice, your EBS volume is also running in multiple availability zones, and your data store layers with a cache, with a primary and a replica, and also a database with a primary and replica. You want to test actions like what would happen if an AZ failure occurs and I no longer can spin up EC2 instances in that failed AZ, or my auto-scaling group also cannot spin up new instances in that failed AZ, or my EBS volumes pause I/O because that's one of the symptoms that we see often during availability zone failures. So in running this scenario, what FIS would do is literally simulate these actions in the AZ that you choose to run the experiment on. And then what you should expect, if things go well, right, is your load balancer shifting traffic to the healthy AZ, the auto-scaling group spinning up new instances in the healthy AZ, your elastic cache and RDS primaries failing over to the previous replicas. So let's show you run through a quick demo of what this looks like. Again, it's a recorded demo because we don't want to tempt the demo gods. But before we go into the demo, just a reminder, the reason why we're doing these tests is, again, it's not just about testing the infrastructure itself, but also testing the resilience of your applications. So we often find customers realizing things like their DNS caches are too long on the OS layer. So when RDS failed over, their compute didn't catch that the primary has changed. Or they realize in the application layer, they didn't configure retries of dependent endpoints that they use. They didn't configure jitter, for example, and then there's a retry storm against that dependency when your application comes back online. So just a reminder about why we do this is to test at every layer of the cake, right? So think about some of the things that you could find in your application when running something like an availability zone failover. So let's get into the demo. Let's go back. Okay, yeah. So what we've got here is a sample application that just allows people adopt pets, right? So the whole idea is, it's 3 different services, 3 different APIs. One is providing a UI, 2 APIs, and a database that runs this application. It's a typical application you'd run. The UI runs on ECS, or rather EKS, while the APIs run on ECS, all fronted by load balancers. The compute for the application runs multi-AZ. The RDS instance is also multi-AZ. So a very, very typical kind of application you've probably seen before and deployed in your environment. And there's a bunch of other regional services that the application depends on, like S3, Lambda. And what we're going to do here is inject the failure through FIS that would kill one of the AZs and simulate that AZ interruption failure. There is a very good blog post that provides GitHub code that you can run this demo on in your environment. So if you want to learn about FIS and how to use it, that blog post is very, very useful. So FIS lives in the Resilience Hub console, and it's under the resilience testing part of the console. You go to the scenario library, AZ power interruption, and click create experiment template. So you can give it, a name that makes sense for your experiment. We're going to run this in a single account. The application runs in a single account, so that's fine. And then next. So here we see the actions that this scenario is going to take. Excuse me. And now we can edit certain parameters that apply to all actions in the experiment, such as which AZ do we want this experiment to be carried out on, right? Which IAM role should be denied from creating new instances to simulate that inability to spin up instances in the impacted AZ. So I'm going to select the right role for the demo here. And then under the advanced parameters there, this is where you can select which resources should be targeted based on a key value basis. So you must have configured your resources with the right tag key and value. And in this case, I'm just going to put ready for all the tag key, the tag values. So I'm going to tag my RDS instance, my Elastic Cache instance with that key value. So again, part of that safety, targeting the right resources to run the experiment on. And then we're going to set the duration of the experiment here. We want the impact to be for 2 minutes, the whole outage for 10 minutes, and the recovery afterwards, so slowly allowing the services back online for 5 minutes. and then it's going to create a service linked role, or we can select one you've already pre-created. And a nice thing about FIS is that it can generate a report for you, a PDF report, that includes essentially all it's observed through the experiment, and it would store that PDF in a S3 bucket for you. And if you've got a CloudWatch dashboard that monitors your application, you can ask FIS to take screenshots of that dashboard and add it to that PDF report that it creates for you. So here I'm saying, take screenshots 10 minutes before the experiment and 5 minutes after the experiment to show that full, life cycle of the experiment. And then you can send logs to CloudWatch, so you see the steps in CloudWatch logs, give the experiment template a name that makes sense, and you're basically done. You can review the actions it's going to take, and now you have an experiment template to run with. Before running the experiment, this is the CloudWatch dashboard for this application. You can see that the auto-scaling groups for the compute has healthy instances in AZ A and B. That's important. Keep an eye on that when you run the experiment. You can see where the RDS writer is. It's in USD 1A. And you can see the database connections are primarily going to the database instance in 1A. So when we now go to the templates and we run an actual experiment, you'll see you can review the actions it's going to take and review the status of each action. There's also a nice timeline view that just shows you the planned actions and where they are in terms of their completion stage. And then back to the dashboard, we'll speed this up a little bit. You'd start seeing things like the instances in AZA are no longer available. The healthy instances has gone to 0, and AZB now has 2 healthy instances for both the 2 APIs that we're running. And then if you go into, that was RDS logs to look at the failover event. And this is the auto-scaling group console. You can see auto-scaling group cannot launch instances in that AZ because of FIS is suppressing that ability for auto-scaling. And then back to the CloudWatch dashboard. So it's going to recover in a second because the experiment is over. The outage is now recovering. You can see that we now have healthy instances in AZA. You can see that middle box there. We see the healthy count per AZ changed from 1 to 0 in AZA, and then in AZB it took over with launching 2 new instances. We can see some application level metrics up there, and the gap that you see there in the latency is that period while the application was recovering. Cool. And in the bottom right there, you see the database connections, changed from the old primary, and now the new primary has taken over for all the database connections from the application. Okay, so that's it for the demo, right? That's how FIS works. It's very, very easy to get started with FIS if you have production workloads running already. If you're already following the best practices, select one of the scenarios and use it in your applications. All right, so one more scenario that I wanted to talk through is the cross-region connectivity scenario. If you're running multi-region applications, this is very useful. One of the issues we see customers face is they build a multi-region application, but then they forget dependencies between the regions, right? They would forget that some parts of the application are still calling the other region, or there's cross-region dependencies. So the whole point of this particular scenario in FIS is to test this. What it would do is simulate the failure of one region. It would, it would kill connectivity between the regions. If you're using Transit Gateway or VPC peering, it stops the connectivity between the two, so you can find those dependencies where you have unknown dependencies between the regions. It would pause things like replication on DynamoDB global tables and S3 cross-region replication. So just like I showed you in the demo, it works in a similar way. You create your experiment, you target the right region to run the experiment on, and if you're using ROP53 ARC, you should expect ARC to move your traffic from the unhealthy region to the healthy region. and you expect to see, replication breaking and cross-region connectivity also breaking. There's a very good getting started guide for FIS specifically. So have a look at that to get yourself up to speed on how to quickly start using the fault injection service. So let's go to the operate phase. So now you've tested your hypothesis. You're now running your application. You have some confidence that it can meet the resilience goals that you have under certain failure modes that you've tested for. The operate phase is where you're doing things like using synthetic traffic to simulate your customer experience on your applications. This is where you're implementing alarming to inform your teams when something goes wrong with your applications, when your application is not meeting your customer's experience. And we see load testing again here for the second time, right? Continue load testing as your application's shape changes and as you change the design and change its implementation. We expect customers to continue load testing. A few good services here are in CloudWatch. CloudWatch is a fairly comprehensive service of observability tools, but specifically in CloudWatch there's a feature called synthetic canaries that can do things like run canary checks on your website or API endpoint to inform you of your customer experience on your website or your application so that you're informed before your customer informs you that, hey, there's something wrong with this API, it's down. So it's a very good feature, in CloudWatch to use in the operate phase. And then in the respond and learn phase, we know things will fail. What counts is being able to respond appropriately using things like auto remediation for known failure patterns. There should be no reason to, have humans going through a very long run book for known failure modes that you need to exercise continuously. So use automation for known remediation patterns. Make sure you have the right escalation paths using tools like PagerDuty on Slack to engage the right teams at the right time when you get those alarms. You also need the right event management processes and systems to do things like communicate to your customers, whether they're external or internal customers that are using your application. And one of the recommendations and some of the things we talk to customers about a lot is have a process in place that gets your teams to ask deep questions about why a failure happened and how to remediate those failures so that they don't happen again in the future. And at Amazon, we have a process called the correction of errors process. It's essentially a mechanism that we ask our service teams to go through that helps them understand the deep reasons why a failure happened and not just isolate those learnings within their team, but these correction of errors actually spread across the whole organization. It's a mechanism that we have within Amazon. So speaking of automation, this is where tools like auto scaling come into play. There are a lot of features of auto scaling that can help you automatically recover failed EC2 instances. Use the features within RDS to automatically fail over. Use Systems Manager with automation runbooks, for example, to respond to known alarms and carry out the runbooks that you would, typically do with a human, right? If you have to wake someone up in the middle of the night to respond to an alarm, it's going to take them a while to wake up, get to their laptop, read the runbook of what they're supposed to do, and then execute that recovery process. So might as well just automate that. On correction of errors, at Amazon, you might have heard of the weekly operations meeting that we have at Amazon. It's a Wednesday meeting that happens US time, and it's run by our service team, and it's actually attended by service team leadership up to the senior vice president level, right? What that shows is the level of commitment Amazon has to resilience. In that meeting, what we do is each service team that's been selected for that call go through their recent outages, their recent COEs, and they do a read of that COE with the rest of the engineers that are on the call. It's often attended by thousands of engineers from across Amazon, and it's one of the mechanisms that we use to scale those learnings from one team, making sure that those learnings scale across the organization. A few tools that help here are things like, I mentioned Systems Manager. I mentioned, features in specific services like auto scaling and RDS. Take advantage of those. take a look at the well-architected framework and white papers for each of those services to learn about what the right patterns are for automatically responding to events there. If you want to read a lot more about the resilience lifecycle framework, there is a very good white paper on this. And remember, you can start at anywhere in the framework. It starts with setting the objectives, designing towards those objectives. When you've designed and implemented and you've deployed your application, test that your application can actually survive the failures that you think it should survive. In the operate phase, make sure that you're alarming. You have the observability best practices in place, and then when things do fail, think about how you respond to those events, in the best way to quickly recover for your customers. I'm going to give a quick shout out to the Skill Builder website. If you haven't heard of Skill Builder, it's a training and certification website that AWS has. It contains over 600 plus free courses, a lot of them on demand, but some are in person, some are paid. There's a lot of content there around resilience. Specifically, there's a lot of knowledge in Skill Builder that helps you deep dive into resilience patterns for specific services. So if you haven't used Skill Builder in the past, sign up, take a look, use your Builder ID or your I think, you have to use a Builder ID to sign up now. And there's a lot of content there to use. So thank you very much. I really appreciate you joining this session to learn about resilience. Good luck with all the applications you build. Thank you very much.